Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot and a PMDG 777 beta tester. Welcome to this tutorial on flying non-precision approaches using VNAV in the PMDG Boeing 777 and Microsoft Flight Simulator. If you're interested in a written tutorial, including even more background information, check out my Ultimate 777 Guide ebook. More on that in the video description below. And now let's get right into it. So Boeing refers to all of these approaches as non-ILS instrument approaches, and that includes anything from RNAV approaches, GPS approaches, VOR, NDB, localizer, and basically anything in between. So anything that is not an ILS. Boeing does recommend to use VNAV for these approaches whenever possible. However, under certain circumstances, vertical speed or flight path angle pitch modes may be required. In this tutorial, we're going to focus on the usage of VNAV. So we are going to start this one with a little bit of background of how the systems work and how everything works. Then we're going to go over how to set up for an approach like this. And finally we are going to fly an RNAV approach into Phuket in Thailand. So this is going to be the RMP Zulu approach, runway 09er, that we're going to use as an example for today's flight. Now, let's go ahead and start with some general backgrounds. So, the VNAV system of the Boeing 777 is very capable and comes with a dedicated approach logic. Boeing refers to this as the on-approach mode. There is no visual indication to the pilot that this mode is active, so you have to have a little bit of system knowledge to understand when it is active and what is different when that mode is active. So generally the FMC transitions to on-approach mode for any of the following conditions: when the descent phase is active and the flaps are out of the up position, when the airplane has sequenced the first waypoint of the active approach, when the airplane is on a direct to or intercept course to the active waypoint and the distance to go is less than 12 nautical miles, or when the missed approach point is the active waypoint and the distance to go is less than 25 miles. Now, the approach condition may be delayed if the flight crew manually inserts, bypasses, or deletes an approach waypoint on the legs page. For that reason, we have to be very careful when we deal with inputs in the legs page, but we'll talk about that in a couple moments. So, when the FMC is on approach, the following features are available to you. The speed window can be opened and command speed can be set while VNAV remains in VNAV path descent mode, so it does not revert to VNAV speed, and then VNAV commands the set speed. The MCP altitude can be set above the airplane altitude for the missed approach, and when the MCP altitude setting is at least 300 feet above the current airplane altitude, VNAV continues to command a descent. VNAV is going to remain in VNAV path and follows the descent path unless the airplane accelerates to within 5 knots of the current flap placard speed and the airplane pitch rises more than 150 feet above the path. In that case, VNAV path changes to VNAV speed to protect you from overspeeding the aircraft. And when a glide path angle is specified for one or more legs on the approach, it is displayed on the legs page, and VNAV provides VNAV path guidance at the displayed angle. Then, when sequencing a waypoint prior to a descent leg specified by glide path angle, VNAV commands level flight until the airplane intercepts the descent path. And we're going to see this as a practical example in a few moments over here on this approach. Now, display of a specified glide path angle is not limited to approaches. A glide path angle may be defined for a leg in a star and displays on the legs page for the procedure. So we'll see that in a practical example soon. Now, let's discuss a little bit further background as for the setup and as for the recommended modes. So, for any non-precision approach, Boeing basically recommends to use LNAV unless it is a localizer approach. In that case, localizer mode is recommended. So it's normally LNAV for anything unless you fly a localizer approach. In that case, you'll use the localizer function. Now, you got to be careful there though. If you use LNAV to intercept the localizer track, then LNAV might parallel the localizer without capturing it. So that can happen. Now, automatic flight is the preferred method of flying non-ILS approaches, as automatic flight minimizes flight crew workload and facilitates monitoring the procedure and flight path. During non-ILS approaches, autopilot use allows better course and vertical path tracking accuracy, reduces the probability of inadvertent deviations below path, provides autopilot alerts and mode fail indications, and enables lower RMP limits. Therefore, autopilot use is recommended until suitable visual references is established on final approach. Now, nonetheless, during any approach that is based on a ground-based navigation aid, so say for example a localizer approach, VOR approach, NDB approach, and so on, it is still recommended that the applicable raw data is monitored throughout the entire approach. Now, during RNAV approaches, obviously we will have to rely on the data coming from the FMS. Now, let's go ahead and have a look into a couple of basics. So, in order to be allowed to use LNAV for the approach, it is very much recommended that the approach is loaded from the nav database and not entered manually. So, loading an approach from the database is required for any RNAV and GPS approaches, and if an approach procedure is selected through the FMC arrivals page, that simply provides the easiest and safest selection of waypoint, ensuring minimum margin for error. No waypoints may be added or deleted between the final approach fix and the missed approach point. If the approach is to be flown from the database, another approach having, or if the approach to be flown is not in the database, then another approach having the same plan view may be selected. So for example, if you want to fly an NDB approach that basically follows the same track as an ILS approach but is not available in the database, then you can select that ILS approach so that you've got a good overlay. However, when you use that overlay method, then raw data needs to be monitored throughout the approach to ensure obstacle clearance. However, if that NDB approach is available in the database, then you should always select the actual approach to be flown. Now, if a waypoint is added or deleted from a database procedure, the FMC on approach logic is partially or completely disabled, and the VNAV obstacle clearance integrity of the procedure may be adversely affected. If an additional waypoint reference is desired, use the fix page and do not modify waypoints on the lex page. So, fix page over here, you can add anything you like, but keep the lex page unchanged as much as possible. What you are allowed to change is the altitudes on the right side of the lex page over here, but only for cold temperature correction. It is possible to manually insert speed restrictions over here, however Boeing recommends not to do it and just stick with the default speeds unless a change is really desired. So let's go ahead and have a look into what we can or cannot do now. So basically, in order to be allowed to use VNAV, we have to have either a glide path angle displayed on the final segment on the lex page. So for example here, we've got the missed approach point MR09, so missed approach runway 09, and we do have a glide path angle available in front of that. Therefore, we're allowed to use VNAV. Now, if no glide path angle is available, then we have to have a runway waypoint or a missed approach point defined on the lex page. Today we don't have a runway waypoint. You can see we've got our FAF over here, HKT Whiskey Fox, and then we've got a missed approach point. So for that reason, even without the glide path angle displayed, we would be allowed to fly the approach like that. However, normally it is required that you either have a published glide path angle, or you have a runway waypoint at the approach end of the runway, or you have a missed approach waypoint before the approach end of the runway. Now, whenever technically available, the autopilot should be used during the approach to give autopilot alerts and mode fail indications, more accurate course and glide path tracking, and lower RMP limits. However, it is not allowed to fly an instrument approach using VNAV when your altimeter is referenced to QFE rather than QNH. So that was quite a bit of theory over here. The first 10 minutes of the video are already over, But that means we can finally go into the actual setup of our arrival. So let's have a look into how we set up the FMC now. To set up our FMC, we basically have to ensure that everything from our chart is exactly like that included in our database. So our approach today is the RMP Zulu runway 09 at Phuket. And that one starts for us at the initial approach fix Lazio, 4,000 feet, maximum 220 knots. And we've got Lazio, 220 knots is in there and above 4,000 feet. From there we continue on a track of 123 degrees, 5.9 nautical miles towards Lausanne. And we have 123 degrees, 6 miles and Lausanne. So at Lausanne we've got a speed restriction of maximum 200 knots and we got to cross that one at or above 3,000, which we've got in the FMC here as well. From there we continue on the final track, 085, 6.9 miles towards HKT Whiskey Fox, and we've got 085, 7 miles, HKT Whiskey Fox. Now that one's in 1700 feet, and that's going to be our platform altitude for this approach. However, since we do have the glide path angle published, the airplane would just level off in 3000 and then fly level at that altitude until we intercept the 3-degree glide path on the approach. Now, since we do aim for a continuous descent, however, we should be able to do it without the intermediate level off, but just be aware that the airplane has that feature installed in it. So, finally then, we've got our missed approach fix 1 mile from the runway, and that one is, of course, located at an altitude that's a little bit further down from what we normally know, and we might not always have an altitude associated with that available in the database or on the chart. For that reason, what we can do is just to apply a bit of common logic. So we can see over here we've got 1 nautical mile between the missed approach point and the runway threshold. The threshold is in 19 feet and the threshold crossing height is 50 feet. So basically what we get is that right at the runway we should have an altitude of 69 feet. Now, if we look into our FMS, we've got 1 nautical mile over here on a 3-degree glide slope that's roughly 300 feet. So for that reason, our missed approach point, which is 1 mile in front of the runway, is located at 388 feet. If instead of the missed approach point we would have a runway point, then we would expect an altitude there of 69 feet. So runway elevation plus 50 feet, as the airplane wants to cross the runway threshold 50 feet above, which is standard for instrument approaches. Next, we need to ensure that our correct minimum is set, so be aware that you can only use VNAV minimums if you indeed fly the approach using VNAV, otherwise you might use the LNAV only minimum. And in case there are several different minimums available for different approach categories, remember that your 777-300ER is a category Delta aircraft. Okay, so now let's go ahead and set our minimum. It's 870 feet. And setting the minimum is quite important. The 777's autoflight system has a dedicated feature that allows you to set the exact minimum altitude on the MCP if auto mode is selected down here. So if you're in thousands you can't do it. In auto you can set it right down to the very exact minimum. So it is important that the minimum is correctly set down here. Now that basically concludes the mandatory setup of our FMC. Of course, we are also going to insert a flap limit, we are also going to set an auto brake and stuff like that. But this is the important stuff, verifying that your legs page indeed matches the procedure accurately and ensuring that the minimum is selected. Now with all of that out of the way, let's go ahead and read the descent checklist in order to ensure that we haven't forgot anything. So let's do that. Tablet, recall, it's checked, notes, checked, auto brake, 3, landing data, Vera 30149, minimum Sparrow 870, approach briefing completed, descent checklist complete. And now comes the next important part. This concludes our preparation. Now, when we conduct the actual approach, first of all, we got to ensure very carefully that we are on the correct QNH. There is no monitoring for altimeter error in the Boeing 777. So if you accidentally select an incorrect QNH, you will end up on an incorrect flight path. Remember, whenever you use VNAV, your entire vertical position is purely based on the altimeter indication that you've got on your PFDs. For that reason, when you are flying the approach with an incorrect altimeter setting, you will have almost no way of spotting that incorrect altimeter setting. The only reference you have is the radio altimeter. And remember that if you approach over land and not over ocean, then you never know if you might have rising or falling terrain, so it can be very hard to detect errors based on the radio altimeter alone. However, nonetheless, always compare your indicated altitude with the radio altitude, taking into account airfield elevation and the terrain profile prior to the runway. For example, today we're approaching over the ocean. For that reason, if the altimeter indication and the radio altimeter indication disagree from one another, that is a clear indication that we have an altimeter setting error. And just to give you an idea, if you accidentally select a QNH of, let's say for example 10 hectopascals less, so for example 1003 instead of 1013, that would mean that you're actually going to arrive at sea level 1 nautical mile prior to the runway. Obstacle clearance is not assured like this, and there have been accidents in the past where aircraft crashed into the terrain just because the altimeter setting was incorrect on a non-precision approach. So, I've just pressed the B key, you might have seen that, and changed my QNH to the current QNH. So when that is done, and when we can read the approach checklist, take that altimeter challenge over here serious. Don't just check that any QNH is set, but use all available means to check that the correct QNH is set. You can always compare it against the latest that was reported on the ATIS. You can always ask ATC to confirm the altimeter setting for you. When that is done, we can complete the approach checklist. So now let's get to the part that you probably came for, and that is how do we actually fly this approach. Now, Boeing recommends that you use LNAV whenever possible to fly the approach, unless it is a localizer approach. In that case, localizer mode is used as it provides even greater accuracy. Now, when we are cleared to intercept the final, ensure that either LNAV or localizer mode is armed, and ensure that LNAV is actually engaged or the localizer is captured. Approximately 2 miles prior to the descent point or the final approach fix as applicable, we are going to call approaching glide path, select the altitude down to our minimums, select or verify VNAV, and select or verify speed intervention with an appropriate speed set. During the entire approach, we're going to follow the standard decelerated approach profile, which means that we basically treat our airplane configuration, so flap extension, gear extension, just like on the standard ILS approach. So try to intercept using flaps 5 at 2500 feet above the ground, gear down, flaps 20, arm the spoilers, open the landing checklist, and when the speed allows, landing flaps, complete the landing checklist, be stabilized by 1000 feet above field elevation, the latest. Now, once we're at least 300 feet below the missed approach altitude, we are going to set the missed approach altitude on the MCP. Ensure that the missed approach altitude is really set only once you are at least 300 feet below it. Otherwise, VNAV might try to capture the altitude and you are basically out of the approach and you can start a new one. So, try to build in some distance to altitude checks, which normally the pilot monitoring would do for you. And once we are on the final approach, visual with the runway, we can disengage the autopilot, make sure to maintain the glide path for the manual landing. As soon as the visual approach aids, that's normally the PAPI, are in sight, we are going to refer primarily to the PAPI. But if you actually have a runway waypoint available in your FMC, which we do not have today, but if you have a Romeo Whiskey whatever point, Romeo Whiskey 09 for a runway 09, then the flight director may be used all the way down to the final approach for as long as it gives good guidance. Now, if the flight director is not available as a reference, select both flight directors off so that they don't interfere with the approach. Now, due to the go-around logic, refer to the go-around tutorial for more on that, due to the go-around logic of the Boeing 777, it may be recommended, and some airlines actually employ an SOP, that the pilot monitoring's flight director is immediately set on again, and only the pilot flying's flight director is kept off for the remainder of the approach. Now, a last little trick that you can apply in order to get a little bit better guidance. If you go to the progress page and then press previous page so that we end up on the RMP progress page, that's page 4 out of 4, then in here we have two numbers that we can modify, that's the RMP value and the vertical RMP value. Now, for an RMP approach, you can see that the airplane has already selected 0.3 as a predefined RMP value. So it's going to set that automatically up here as soon as we pass Lazio and start the actual approach. What the airplane is not going to do is to change the vertical RMP. And here is a little trick from real-world 777 operation. If you want to fly the approach and get automatic alerting for when you exceed the maximum deviation, then you can enter a vertical RMP of 125 feet. Now, when you do that, so 125, put that up here. When you do that, and your actual altitude exceeds 75 feet deviation from the FMC calculated altitude, you are going to get an amber scale on your primary flight display, alerting you that you exceed the maximum allowed deviation from your flight path. Remember, on non-precision approaches, plus minus 75 feet, is the acceptable deviation, and when you enter the vertical RMP of 125, then at 75 feet deviation you're going to get an amber bar on your primary flight display, alerting you that something is wrong with your setup. So that's a very good thing to do. It's not standard operating procedure with many airlines. Some have that as SOP, but most don't. But just a very nice trick from actual 777 operations. So now let's go out of the active pause and we are going to start our approach. So let's just do a quick reminder of the most important things for us to remember. So, coming in on the approach, we try to maximize the use of the autoflight system, that's LNAV and VNAV. Only for a localizer approach we would be using localizer mode. Maintain good control of your airspeed, and Boeing does recommend that you don't keep the speed window closed, but that you actually open it up. But don't do that too early, since opening the speed window too early while the FMC is not yet in approach logic is going to give you VNAV speed. So let's go ahead and close that again, so that we remain in VNAV path mode. Once the FMC is on approach logic, you can open the speed window, and the airplane is going to remain within VNAV path. Now, the easiest way to force the airplane into approach logic is to get the flaps out into the first setting. You've got a rather high flap limit speed here, 165 knots for the first flap setting, so normally you are going to have that option available to you pretty soon. So, we are now approaching Lazio, which is the starting point of our procedure. 220 knots is our speed difference. Remember, the 777 does not protect you against underspeeding, so flying below the current maneuvering speed. So always remember to get the flaps out as early as possible so that this does not happen. So the next altitude we can use now is 3000, as that is our minimum at Lazam. So let's go ahead and insert that in our MCP. So 3000 is in. Now, keep a good eye on your airspeed, as the 777 is not always excellent in speed control. So remember that we have to slow down early enough so that we don't get a rushed or a hot and high approach. Now, as we're approaching our final descent, remember 2 miles prior to the final descent, we are going to set our MCP altitude down to the minimum, verify or engage VNAV, and open up the speed window so that we have manual control of our airspeed. So just to show you, now that the flaps are out, if I open the speed window, you can see it remains in VNAV path, and does no longer revert to VNAV speed. So the on-approach logic of the FMC is now active. Okay, let's get out the flaps into the 5 settings so that we can start reducing our speed further. And remember that we are going to follow our standard deceleration schedule. So let me get out a couple of speed brakes over here. Okay then, overflying Lazam, we can descend down to 1700, which is our final approach fixed altitude. Remember that on a non-ILS approach that is flown in LNAV, we don't have automatic setting of the runway heading, so we got to do that ourselves. Alright, so we now have 1700 feet at our final approach fix. Things are going to get hectic once we're approaching that. So let's just revise what we are going to do next. 2 miles prior to the final approach fix, we're going to set our altitude down to our minimum, that's 870, and as soon as we are at least 300 feet below our missed approach altitude, so missed approach altitude 4,000 feet today, in other words, we basically are going to be below that straight away. So once we're past the FAF, we're going to set our MCP up to the missed approach altitude of 4,000 feet. Configure the airplane as normal, and once we have our landing runway in sight, we can disengage the automatics. Now, since we do not have a runway waypoint today, we have to turn the flight directors off once visual references are established, and we are going to switch on the pilot monitoring flight director again, so that we are prepared for a go-around. More on that in the go-around tutorial. Okay, so we're 2 miles prior to the FAF. I'm setting the altitude down. And as you can see, since I've set a minimum of 870, we're actually able to set 870 on our MCP as well. So, over at the FAF, we're supposed to be in 1700 feet. And here we are, overflying the FAF, 1700. We are more than 300 feet below our missed approach altitude, so we can go ahead and set the missed approach altitude now. And as you can see, the airplane keeps descending on it. Our landing checklist is complete. So all we got to do now, since we have our runway in sight, disengage the autopilot, flight directors off, and only the pilot monitoring flight director goes back on again. On the pilot flying side, since we do not have vertical guidance available, on the pilot flying side, we are simply going to remain without the flight director so that we can focus on maintaining the visual approach path. Now, what you can do is to use the flight path vector, which normally gives you a little bit of good guidance here as well. So, plus 100 is checked. We start getting the puppies inside over there. Continue. And from here on, we just go ahead and land our aircraft. So I do hope that you found this tutorial interesting. If you did, be sure to let me know in the comments below. Leave your feedback. And if this landing is becoming a good landing, then I would appreciate if you also leave a like for the video. Comment to let me know what you think of it, and subscribe if you're up for more. Finally, if you really love what I'm doing here, I would appreciate a small donation through the Buy Me a Coffee link in the video description below. But now, let's go ahead and focus on the landing and make it a good one. So, speed brake up, thrust reverse normal. And here we are, my friends. So, as always, if you're interested in reading up on anything that I've shown in this video and that I've explained in this video, check out my Ultimate 777 Guide ebook. More on that in the video description below. And for now, I would like to thank you very much for watching. Like, comment and subscribe, and then I'm looking forward to see you all again on the next one.